All right, what's up, guys? Today we got some really nice problems. Now I know that this is mainly a physics channel, as I've clearly stated, but it's important to remember math. Maths are fundamentals, right? Math is the boring stuff that those mathematicians do for us, and they're stupid for doing it. So, but we need it now because for physics. So we didn't know how to do it, even though it's stupid and it's bad and I hate it. So today we're gonna do some pretty elementary problems, and I'm gonna just go through them just to reinforce the fundamentals. All right, 3 times 3. Right, so we could imagine there being this square right here, or rather rectangle, and it just so happens that the top has the top has three units, and the side has 3 units as well. And then we can just count the number of units we've got here. So that's 1, 2, 3, 4, 5. Sorry if I'm going a bit too quick. 6, 7, 8, 9. All right, so 3 times 3 is 9. That's pretty simple. And 5 times 6 is 30 by the same logic. Won't go too in depth into why. Now, for 3 times 4, you might want to construct another square-like object with that one. But the thing is, we can do one better. We can just add 3 to 3 times 3 to get 3 times 4, because 3 times 3 plus 3 equals 3 times... We can factor out the 3, so that's 3 plus 1. And that's 3 times 4, right? So we can just add 3 to 9. Now, the naive thing to say is that 9 plus 3 is 12. That's, of course, not correct, because we're being physicists right here, so we need to take into account significant digits. And, of course, we only have one significant digit here, because there's only one significant digit there and one significant digit there. And even if there were 2 significant digits, well, doesn't matter. So as long as one of these has one significant digit, then we got one significant digit. So this is, of course, only 10, not 12. It is not 12. If you write 12, that will be wrong. 12 is not correct for this, because we're talking about, we only have one significant digit here. If it was 3.0 times 4.0, yeah, sure, that's 12, but that's not the question. Our question was 3 times 4. Okay, another problem here, 16 times 3. Now that's something that's very hard. Obviously, you couldn't do 16 times 3 in your head. That would be insane. It would take like a supercomputer to do that. I mean, you could take Wolfram Alpha, you could look up 16 times 3 there, but that's just tricky. So there's much more clever thing you can do, and that is to notice that 3 only has one significant digit, much like it did in the last example. But 16 has 2 significant digits. But we can only go down in significant digits. We can't go up. So 16 times 3 is in fact the same thing as 20 times 3, because of course we need to round up. And 20 times 3, that's somewhat trivial, but I'm just going to write out a rectangle just in case. We can't assume anything unless we are assuming everything, in which case that is completely fine. If it's very basic stuff, then we can't leave it up to chance, because my brain is too stupid and I might make a mistake. So 2 times 3 is 6. So when you put a 0, that's 60, right? Just so I don't look like a total idiot online, I'm actually going to take my calculator right here, and I'm going to write Texas. So we got 20 times 3. Now this is a math calculator, so if we were to put in 16 times 3 right into this, we'd get it wrong, of course. But 20 times 3, because we got it like in the right significant digits, we did get 60. So I did make the right decision there. Whew, that was scary. So 5 plus 5 plus 5. Now that's a tricky one. So gotta make certain that we have So that's 5 plus 5 plus 5. So, well, ultimately, we need to take 5 plus 5. That's going to have to be 10 right there, right? That's 5 and 5. That's, yeah, I think I can do that one in my head. That's 10. So that's 10 plus 5. Okay, this is a much easier one than the previous one as it happens, because 10 plus 5, that's just 20. Right, this is for the same reason that 16. This was basically the first step to that one, except we had one smaller number, and that doesn't matter. 300 plus 1, this is like a joke one. This one's so easy. 300 plus 1, that's just 300, because this 1, that's tiny. That's not going to affect anything. That's not going to make it go up. That would be preposterous. We only have well, it depends on who you're talking to, whether or not this is one significant digit or 3 significant digits. Some people might say that 3 times 10 to the 2 has one significant digit, and that 300 has 3, because all of these count. Depends on who you're talking to, but and it depends on where you actually got your data from, but 300 plus 1 is 300, just simply because of the fact that this is 2 magnitudes greater than that, and so we can safely ignore it. 60 plus 9, this is, of course, 70. No issues there. I don't even know why that's a problem. That's peculiar. I don't know why you would even include that. Stupid. So, I don't know if you can read this right, but it says 18 cubed right there. And that might be hard. 18 cubed, I don't know what that could possibly be. But again, we can do the same trick as we did up here, and we can round up. Because, well, of course we can, right? It's like, I mean, sure. Alright, so sorry about that. My setup here is quite ghetto, as it were. So I was sorry for any inconvenience that the sudden fall happened. So where was it? Oh yeah, so 18 cubed, that's just, this is awkward because I already just filmed so much stuff, but 18 cubed, that's about 20 cubed, because, I mean, just going by, like, the same logic as here. I mean, not the same logic, because, mind you, this one did have a 1 significant digit here, but just mind you that this is a 20 cubed, it's about right. I mean, there is some offness that you're going to have there, but it's about right. Tell you what, I'll actually draw a squiggly line to tell you, and I'm not going to formally define what that squiggly equals means, because this isn't math. I don't have to justify everything to you. What are you, my wife? So 20 cubed, I actually calculated this between takes, so embarrassingly, I actually got a 6,000 there, but it's actually an 8,000. Whew. Glad that wasn't recorded. Hooey, that mix-up. But anyway, don't hate me for that. Don't yell at me. Don't. I know this is the internet, so I know you're all gonna be like, this person, can't even make things multiply. But you know, I'm not a computer. I'm a human being. And unlike computers, I have feelings, and also unlike computers, I can't do simple arithmetic in my head, so, you know what, your words might hurt, but that's just for a time. And you know what, I don't have to share my life online. This isn't like a requirement for existing. I could just as easily not exist and still upload, or not upload, rather. But I'm doing it, I'm putting myself out there, and that I think should be rewarded. And the fact that it's not being is just hateful, and especially being rewarded with your hate and your mean comments is just unacceptable. So next one is 10 over 3. Now, of course, this one, you still only got 1 significant digit right here. This one we had 2, but that's not important. But, this one we only have 1. So, 10 over 3. Well, that's just gonna be 3.3 repeating, as your mathematician friend would tell you. But if your mathematician friend tells you that, you need to kick him right in the nuts, cause because that's not right. The answer is 3, because you only got one significant digit. Now, you might think that contradicts 3 times 3 is 9. And indeed, if you take 10 over 3 times 3, that would of course be just 3, because from right here, that's 3. And we're multiplying it by 3. This 3 is a different 3, so you got 3 times 3. And of course, from this one and this one together, well, from this one, we can say that that's 9. From this one, that's 10. So you got 10 equals 9. And you might notice that these two have the same number of significant digits. So for the next one, log 2 over 2. Now, I know a lot of you people might like it more if I said natural log of 2 like that, but that's not the way I'm doing it. I'm doing it a different way. I'm using log. Now, that looks like the general base form. You might think like there should be a base b there or whatever, or maybe I'm talking about base 10, or there's somewhere else in this that I'm saying what base it is. But no, I'm just going to write log, like the word log, so I write as many letters as possible to refer to the natural log. That's what I'm doing. If you don't like it, you can get out. You can just get out. So, log 2 over 2. Now, you think, oh geez, I need to put that into a calculator. I don't know what log 2 is. But you need to remember that log 2 is, let's see, 0, and then there's log 2, and then there's 1 over here. And there's like a strictly decreasing thing. Log 2 is less than 2. Because of course, E is pretty big. E is bigger than 2. So when you take the log of both of those, that's log 2 is less than 1. Maybe I should have done it in this order. Hooey, I'm stupid. But and we know it's positive because otherwise it'd be like less than 1, and it's not. So 2 would have to be less than 1, which is, so well, that's good and all. But as it turns out, this is actually is also greater than 1/2. Now I'm not going to prove that because why would I need to do that? So it's between 1/2 and 1. And we're dividing it by 2, so that's 1/4 log 2 over 2 1/2. So this is just, this is just less than 1. I mean, yeah, it's about less than 1. I mean, like, the thing is, but, like, we can do better. We can say that the limit as 2 approaches infinity of log 2 over 2 actually equals 0. That might be, like, a bit confusing to you, but of course, 2 is just a number, so it can approach infinity. And so when you take the log of 2 over 2, well, log is going to grow much slower than just 2, so we know that that's just going to approach 0. Alright, that's the video. Hope you liked, hope you commented, and sure as hell hope you subscribe. Thank you.